Hey guys, and welcome back to another episode of Science at Home. Today's episode we're going to learn all about soap and how it can tear apart grease and oils and fats to make things all clean again. It can even destroy viruses and bacteria. So let's go learn all about it now. So in order to understand how soap works, we're going to have to do a few different things. First of all, I want you to think about what sort of things are we usually trying to wash away when we're using soap? Well, it's usually greasy, oily, fatty, greasy things. Yeah, that's what we're trying to do. And there's a simple little experiment you can do to see why water isn't so good at doing this on its own. You just need some water, some type of oil, cooking oil, vegetable oil is fine, some type of glass, and just something to stir it with. So we'll start by pouring some water into the glass, yeah? Okay. And now we're going to pour in some oil. We're going to see what happens. So we pour the oil into the water. And what you're going to notice is that the oil does not want to mix with the water. They separate completely. Okay, so we can see the oil here floating on the top and the water underneath, and they do not mix. We can even try stirring it. Yes, stir it really well. Stir it really well to try and mix them up. And what you'll find is, even after stirring it really well, if you give it a little minute, you'll see that the oil and the water still won't mix together. They do not want to mix at all. You'll see the very same thing if you ever tried to wash a greasy saucepan with water. It just won't work. The water doesn't want to attach to the grease, and all you're doing is just moving grease around, and it's awful. You can't get the grease to go with the water because it doesn't want to mix with the water. So oily, greasy things like that frying pan I was trying to wash, or like this butter that I've spread out here, they have a property called hydrophobicity. What is that? Well, it means they're hydrophobic, and that means they're afraid of water. And that just means that oily, fatty, greasy substances want to push away at water, and water wants to push away at them. They don't want to mix. Now, there's another thing that water has that makes it difficult for it to actually wash away these things as well. It's called surface tension. And I'm going to show it to you doing this little experiment. I'm going to take some water up here to my little pipette, and I'm going to put a little drop of water onto this butter here. Now you can try the same yourself at home. Put a little drop of water onto the butter, and what do you notice? The drop of water doesn't spread out over the surface. It's up in a kind of a dome shape. Yeah, because the water doesn't want to spread out because the material is hydrophobic and there's surface tension that's holding the water together. And what does that mean, surface tension? Well, water essentially really likes itself. So all the water molecules at the surface all hold on to each other. Imagine that they're holding hands, for example. They're holding hands really tightly and they don't want to let go. So they form a kind of a skin around the surface. They don't let it all collapse and spread across the butter. They form this tight skin, and that's called surface tension. And we can do another little experiment that can really clearly show that. Okay, so if we really want to get a visual of this surface tension effect, we can do another experiment. Here all you need is a plate, a white plate is easiest to see it on. Some sort of fine pepper or some sort of powdery substance that will sit in the top of the water. Finely ground pepper is perfect. You want some water and you want a little bit of washing up liquid. So we'll start by pouring the water on. Okay, just enough to kind of fill the plate. Then we're going to take our pepper and we're going to grind it as finely as we can. Now it doesn't have to be pepper, it just needs to be some type of very fine powdery substance that you can make float on the water. Now the reason this is floating on the water is because of surface tension. The pepper itself is actually heavier than the water, but all those water molecules, remember, they're all holding hands and they're pulling really tight to form this skin, invisible skin, along the top of the water. Now I'm going to put a little bit more pepper on even, just so we can really see it clearly. Okay, it's all floating on the water, being held there by the surface tension. Now, what's going to happen if I put washing up liquid on it? Washing up liquid is just a really strong type of soap, and it works really well for this. I'm going to put one teeny tiny drop of washing up liquid right in the center. A really tiny one is all you need. Here we go. You watching? See that? It broke the surface tension straight away, and all of the particles of pepper got flung right to the very edge of the plate. So what soap can do is it can break the surface tension so that now all the water will spread over all those greasy, fatty things, and they'll get into all the little nooks and crannies of the little thing that you're trying to wash. So we've seen how soap can break the surface tension of the water, and that's really useful for getting the water into all these tiny little nooks and crannies to try and wash things up. But there's something far more important that soap can do, and it's all got to do with the shape of the soap molecule. Okay, now soap, like everything else, is made up of little molecules, tiny, tiny little particles. But the soap molecules has a very specific shape and design. Soap molecules have a head and they have a tail. Now the head is hydrophilic. That means it's attracted to water. It really wants to be near water. But the tail is hydrophobic, which we said already means it's afraid of water. It pushes water away, and it's actually attracted to fatty, oily substances. So if you mix the soap in the water, you have millions of these little soap molecules drifting around, and if they find oily, greasy stuff, the tails of the soap molecule bury right down into them. They want to get right in to get away from the water and into the fatty, oily things. Now the water sloshing around, is going to pull on the heads of these soap molecules. So that causes them to pull away, and they drag all that oily, greasy stuff with them. Now, any other soap molecules knocking around will get attracted to them as well, until you have a whole sphere surrounding your little bits of oily, greasy fat. And the outside part of that sphere is hydrophobic. Therefore, it's carried away by the water, and you wash it all away, and all your greasy, oily stuff is all gone. So this brings us to our last point. Why is soap so good at killing viruses and bacteria and other germs and bugs like that? Well, it's all got to do with what the viruses and bacteria and stuff are. So a virus, just like the coronavirus, is just a little ball of genetic material that's all wrapped up in a kind of a fatty, greasy outer layer. They're just little grease balls, really. And if soapy water comes into contact with them, those hydrophobic tails of the soap molecules are going to try and get away from the water, and they're going to burrow their way right into those viruses. And it's almost like 1,000 little pins sticking into the virus. So this actually tears it apart and breaks it open and kills the virus. And all the other soap molecules come around and surround those little parts, form those little hydrophilic balls, get washed away, and suddenly your virus, your bacteria, your germ, whatever it is washed down the drain. Now, this is why washing your hands is actually even better than using hand sanitizer, because those soapy molecules get in there and really destroy everything. And it's important to wash really well to get that soapy water into all the little nooks and crannies, take any germs and bugs and viruses and wash them all away. So now you can see that we can really get all of that grease and oil and dirt off when we use the soap. And we know what the soap molecules are doing. They're digging their way in there and they're getting washed away in the water. And we can see it even better if we look back at our glass of water and oil from before. So we can take some washing up liquid, and if we add it, we'll see that they'll mix now. So we can see that they're completely mixed together now. And remember, this is what our soap molecules are doing. One side is attracted to water, one side is attracted to the greasy, oily stuff, and that enables water and oil to bind together. So thanks so much for tuning in, guys. I hope you get a new appreciation of soap when you're washing your hands, washing the dishes, or washing your clothes. So I'm going to go wash my hands. Thanks again for tuning in, and we're looking forward to seeing you on the next one.